Hey everybody, this is Mr. Storm, and in this video, we are going to make a completely original game called Flappy Fish, okay? Flappy Fish, not Flappy Bird. Flappy Bird's something completely different. For this, it's Flappy Fish, right? As we can see, he's a fish. He has the fish eye and fish wings and a fish beak and fish feathers. So he's a fish. He's not a bird. Yeah, you get me. So this project already has everything in it you need in order to finish the game. Now, here's the thing. This game is supposed to be kind of like an endless runner game where, you'll go forever and then there's no end to it and you just kind of see how long you can survive. The problem is in order to make that work, it's going to require a lot more programming than I want to get into at this early stage. Right now, I just want this to be more of a fun project using some of the things we've already learned, but also kind of learning one or two new things that, will be helpful in the future. And not getting too crazy into tricking Unity into doing what we want it to do. So what I've done is I've established an end of the level here so that whenever you hit the end, you actually restart at the beginning of the level. So it is kind of endless, but it's not really endless, right? This game has only one scene, and it has all of the objects ready to go, built ready for you to go. There is a top boundary here as well. So if your fish gets too high up in the game, they will come back down or the game will restart. Let's see, that's about it. So let's actually get into how to make this fish do what we want it to do. So he's swimming in the ocean here. And what we want the fish to constantly move to the right. And we want to hit the space bar. When we hit the space bar, we want it to apply some force, kind of pushing the fish up momentarily, and then allow gravity to bring him back down. If we take a look at our fish object here and the rigid body, we're allowing the gravity scale to stay on for this game because we do want there to be some gravity. We want him to fall back down to the ground. So let's take a look at what happens when I play this game. So he falls to the ground and just stays there, right? Notice that he already has a swimming motion. That's swimming, not flying. Okay, he's in the water. He already has a swimming animation, which I've built in there. Now I can already tell that the edges of the sprite aren't great, but whatever. This is just for fun anyway. Excuse me. So let's actually get into programming this guy, making him do what we want him to do. I'm going to create a new folder, and I'm going to call this scripts. And inside the scripts folder, I'm going to create a new C# script, and I'm going to call it fish controller, because he's a fish, right? And then I will attach my fish controller script to my fish buddy. That didn't work. There we go. Attach them to the fish, make sure I have my fish controller script. It is there. Beautiful. Let's go ahead and open her up. Okay. Open up my notes here. So we have our start method and our update method. And we're actually going to need both for this game. One second. Just adjust something on my other screen here. Okay, so we need both of those for this game, but let's think about the variables we're going to need. Well, we're moving to the right, but we need to move at a specific speed. But before we do that, actually, we need to create a reference to the rigid body on our fish to make our programming a bit easier. So let's create a private reference to rigid body 2D. Call it player. All right, and then let's get into our public methods. We want a public float speed, and let's set the speed to 2. And then the other thing that we want a public variable that handles how strong is our thrust whenever we hit the space bar. How much force do we want to give it whenever we hit the space bar? How strong is the flap, right? That's my flapping motion. Do you like that? That's Flap. How strong is the flap? So let's create a public float. We'll call this force. And we're going to set this to 300. He's going to be powerful. A powerful flap. Now, if you're wondering, we're moving it too, but we're applying 300 pressure up. Well, here's why. The method that we are going to, not the method, but the method, the add force method that we're going to use is a little bit more, it's more sensitive than our vector2.write that we're going to use, right? So 300 is a good number for force. If we did 2, then it wouldn't really apply any force at all. Okay, so inside the start method, we need to get a reference to our rigid body. So get component, if I spelled it correctly, rigid body 2D. Now I'm noticing something as I'm typing here. My Visual Studio environment isn't automatically trying to finish my sentences here. It's not trying to fix it, which means I think I've lost my connection to the Unity API. It should be fine. It's just I'm not going to get that little bit of extra help that we normally get. If that happens to you, then, suffer through it with me. Okay, so now that we have a reference to the rigid body for the player, now I actually want to start my player moving to the right as soon as the game starts. If you remember, when we did player movement, we handled this inside of the update method because we wanted to check to see if something was happening before we started moving. In this game, though, we want the fish to move by itself. We don't want movement to be based off of user input. And so we can just set it to start moving right at the beginning of the game. So player.velocity. Yep. And we'll say vector 2. Oh, 2. No, 2. Vector 2. Now, right here, before I keep going, I can tell right now that this is going to try to create, because I've lost my link to Unity somehow, this is going to try to turn this into a bit vector 32. As soon as I move on from this, it's going to change what I've typed. I don't like that. It's not great. It's not my favorite. I'm going to go up to Tools and Options. And let's see. Show status, documents and section, find and replace. No. Where is... There's something that allows me to turn off. Let's see. There's something that allows me to turn it off so that, responsive code completion right there. And require, I don't know what that does, so I'll leave that alone. But responsive code completion, I'm going to turn that off because I don't want it to automatically finish my sentences because I've lost connection to the Unity API. So, okay, good. Speed. Okay, cool. Sorry for that little detour. I just, I knew it was going to drive me nuts if I kept typing vector 2 and it was trying to replace it with something that I didn't want, and I'd have to go back and delete the parts. You get it. So what we've done here is I've taken that reference to the rigid body 2D. I'm going to change the velocity, and I'm going to change it to actually start moving to the right at the speed that we've set, right? That's pretty much it. Now, we've done this before plenty of times, so by now this shouldn't be confusing. The only change is that we're not basing the direction he's moving on user input, and we're not putting it in the update method. We're putting it in start because we want it to start right away. Remember, the start method executes code as soon as the game starts or as soon as this script exists in the game, whereas the update runs every frame, right? Okay, so that's good for the start method. Let's see, what do we need to do in update? Well, in update, we need to handle our jumping or our swimming, our flapping, right? And so we need to wait for a specific button to be pressed for that. Now we could handle this using an input axis, but I already know what button I want it to be, and I don't want to change what button it is. I'm just going to access a specific input by its button. So we're going to say if input.get key down, and let's say key code dot space. So if I press the space key, if that space key is, if space is pressed down, then we will player dot add force, and we'll say vector 2 dot up times force. That's what I want. So player dot add force vector 2 dot up times force. So again, this is basically the same thing as what we're doing here. Instead of changing the velocity, we're adding some force to the game itself. Now notice that with velocity, we were changing the velocity and we were setting it equal to a specific thing. This down here, this is actually a method call. We're calling a method called add force that's attached to this player object. And that method requires an argument, and that argument is the amount of force and which direction we want it to go. So we're going to go up with a certain amount of force. Okay, let's see, what else do we need for our fish? Oh, we need to figure out if we've collided with any walls and reset the game if we have done so. So what we need to do is, well, we're resetting a scene, so we need to bring in a new library using Unity engine.scene management. Okay, scene management. That way we can reset the scene that we're in. And we need to bring in a, let's say, void on collision enter 2D collision 2D. We'll call this cull. And we'll just say scene manager dot load scene. And because we only have one scene in our game, we can just call it by name. Load scene main. Okay, that's the entire fish script, fish controller script here. Let's save it and see if we have any errors or misspellings or anything like that. We'll go back to Unity here and let its debugger do its job. Okay, everything looks good here. Let's check my console. Nothing in here. So let's go ahead and play this game and see if our game behaves the way we want it to. Okay, so right now I can tell that when I collide with an object, the game is restarting like it's supposed to. And now I can also tell that my flappiness works, and where'd my fish go? He's off the screen. Well, we need to tell our camera to follow our fish so that, oh, hello, my editor's crashing. Well, that's fun. There is no fix available. Interesting. Well, let's see if... let's open it back up again and see what happened. So I'm going to keep this in the video because it's important that you guys see that sometimes things just happen to me too. And you got to be able to, just kind of carry on. I'm in the middle of recording a video. I'm what? 15 minutes into the video and then the whole game crashes. The whole thing crashes. That's okay. It came back up pretty quickly. Let's check our fish here, and let's check our script to see if we lost anything there. No, we're good. Okay, perfect. So good to go. Nothing is destroyed. Nothing's gone. All right. So next we need to create a camera follow script. Basically, we need to tell our camera that it's going to follow this fish wherever it goes on the screen. So I'm going to create a new C# script called camera follow. And I'm going to attach that camera follow script to my main camera. All right, it's there. Good, good, good. And let's open up camera follow and get started programming. Now, believe it or not, this camera follow script is incredibly easy. First, we do not need a start method. We need one variable, and that is a reference to the object that we are going to follow. So it's going to be public transform. Excuse me, that's not what I wanted. I don't want this library either. Did I not? I turned it off, right? Let's do that too. That's weird. All right. So this crypto API transform method keeps trying to come in. I'm just going to, hopefully we can ignore it. Target. Okay, so I'm trying to create a reference to an object in the game, but I don't actually want the entire game object for this script. All I need to do is access the transform component on that object. So if we look at our fish here, notice that he has all kinds of components attached to him. The first thing he has is this transform component, and I just need that transform, a reference to that transform object, because I'm going to access its X position in this script. The only thing I want my camera to do is I want it to change its own transform to match the transform of this reference object. Now, some of you are thinking, "Hey, Mr. Storm, I've seen other other videos that you've done where you've just made the camera a child of the player object, or I've watched other tutorial videos that just made the camera a child of the player." And that's great, but if we did that for this game, the camera would go up and down as the fish flapped around, which is not what we want. We want the camera to stay steady on the y-axis and only follow on the x-axis. So, so this is how we do it. Let's do transform. Now, again, it's going to try to pop that in. I'm going to click that box so it doesn't. Dot position equals new vector. Oh, again with that vector 3 target dot position dot x. So the first number in the vector 3, or the first variable, I guess, data point in a vector 3 is the X axis. So the reason why we're using a vector 3 here is because our camera is technically a 3D object. The camera, not only does it have an X and Y, but it also has a Z, because the camera can be zoomed in or zoomed out, right? And so with cameras, we have to use a vector 3 instead of a vector 2. Our player is a 2D object, our camera is a 3D object. So the first thing we need to give it is its position on the X axis, and we want to tie it to this targets transform dot X, okay? And then we want to change our transform. Oh, there's that crypto API. I forgot to see. This is bugging me. Let's get rid of that. Get rid of this library we don't need that came in automatically because I tried to access a method in there that we didn't need. All right, transform, and I'm going to turn off. Thank you. Dot position dot y. So this is basically saying keep our own y, and then transform. I'm going to just copy this. It's probably going to be easier, so I don't have to deal with this thing trying to. Hello. Control V. Whoa, hello. What happened there? It copied it, or it pasted it in there twice. Okay, so here's what this line of code is saying. We're going to create a new vector 3, and we're going to reset our position, our own position, meaning the camera, our own position based on these 3 values we set. So the X is going to be the target's X, the Y is going to be our own Y, and the Z is going to be our own Z. So all this script is saying, basically match our X value in our position component, or in our transform component, with the target's transform component. That's all we're doing. And that's it. That's literally it for our camera follow script. So let's save this and go back to Unity and let it update. Now there's one more thing we have to do before we test this out. We have to go take a look at our camera here. Notice that we're looking for a public reference. We need to tell it which target to follow. So I'm going to go ahead and drag my fish boy over into here and drop him in. Could be a fish girl too. I don't know. He looks more like a fish boy to me though. Drop him right in there. Now we're going to follow this fish when we play the game. So I'm going to go ahead and play it. Oh, hello. What's going on? Does my fish not have... My fish doesn't have his script anymore. That's just what happens, I guess, when your entire project crashes in the middle of recording a video. Okay, good. Now we can play. Okay, and look. And so our camera's following along with our fish as he's moving. And you can see that the game is working pretty much exactly the way I want. Now, if this game is too slow for you, you can always change the speed because it's a public variable. You can bump that up. You can also change the flapping force to make it more dynamic if you want. Now, there's one more thing I want to do. This game is fine. It's easy. It's great. The problem is these obstacles here, they don't really do anything. They're just kind of sitting there, and that's really boring. I want to add some more movement into this game. I want to add some difficulty, add some variability into this game. So I'm actually going to create a new script, and we will call this Wall Mover. There we go. Wall Mover. And this is going to be a script that will move our walls and make it, you know, kind of add some fun movement into the game. So I want to attach this wall mover script to every wall in my game, all 13 of them. So I'm going to select the top wall, hold shift and select the bottom wall to make sure I select all of them. And then I will drag this wall mover script over here and just dump it in. So now every wall has the wall mover script attached to it. All right, let's go ahead and open her up. And let's go over here to my notes. Okay, so with the wall mover script, this is actually pretty easy as well. Hopefully you're seeing that, like with most games, especially really simple games like this, there's not a lot of programming, and this script is kind of, or this project is kind of the same. There's really not a lot of programming involved in this project. So we need two variables for this game. We need a public float speed variable. We'll set that to 1. And then we're going to need a public float, let's call this switch time. And I'll set that to 2. Now what this is going to do, we want to set the speed that the walls go up and down. And we're going to set our switch time to be how long does it move in one direction before it reverses course, before it reverses direction. And in order to make that happen, we're going to have to use a new thing that we haven't used before, but we'll get to it. First, let's get our things moving. Get component rigid body 2D dot velocity. Now you're thinking probably, hey, why aren't we creating a reference to the object and then doing it because we're only going to access the rigid body once in this script. And so with only accessing it once, I don't really need to create a reference to the rigid body. I can just type it out like this. It'll actually save us some time. So we're only going to set it moving in the start, and then we're just going to let it keep going. So it's going to be a vector2 dot up, and we're going to set it to move at speed. This is something you've seen before. We've done this already once in this project, and we've done it in every project we've already created. So this should not be a mystery to you right now. I actually don't need the update method for this project, but I do need to create a custom method And let's call this, actually, let's call it void. Let's call it reverse. That looks good to me. And the reverse method, this is just essentially going to reverse the direction we're traveling. Oh, see, and I lied. I am accessing the rigid body again. So I should have probably created a public reference to it. You know, I'm going to do that now just because it's good practice. Call it wall. Times speed. Okay, so there we go. Do. And then down here, I can just say wall.velocity equals, actually, we're going to do times equals -1. Do you remember that trick? Remember that trick from the rat race project, where whenever our rats hit the wall, we reversed our direction. So right now we have basically everything we need, except we have this reverse method that we can't access. That we don't have a call. We're not calling that method in any way. But we want to call this method. We want to reverse direction at a specific time. We don't want to just do it whenever. We want to call it at a specific time. So we're actually going to use a new method that we've never seen before called Invoke Repeating. So inside the start method, I'm going to call Invoke Repeating. Spelled that correctly. Now, Invoke Repeating takes two arguments. The first, or three arguments, sorry. The first argument it takes is the name of the method you want to invoke. So for us, it's going to be reverse. Then the second argument is how long do you want to wait until we start invoking these? And we're going to say 0. And then the third argument is when do you want to repeat it? At what interval do you want to repeat? And for us, it's going to be switch time, as you can see there. So what this invoke repeating method does is it's just going to call reverse every 2 seconds. Every 2 seconds, okay? So if that is everything, I think we're good. Let's go ahead and save this. Come back over to Unity. Oh, hello. I've got an error. Let's see what my error is. Cannot implicitly convert type. Oh, I see what happened. I know what happened. Hold on a second. Let's let that finish. Okay. Over here, I created a rigid body wall. I needed to create a rigid body 2D. I forgot that part. Okay. Now let's see if that error goes away. It does. Okay. So if we look at our walls now, we can see that we have two variables. We have speed and switch time, right? So if we play the game, if we leave everything at speed 1 and switch time 2, then you'll notice that the walls go up and down and they reverse direction at the same time. But that's a bit boring too. So we want to actually vary this up a bit. Let's just grab some walls at random and change their speed maybe and their switch time. Let's keep this one stationary, so speed 0. Let's make this one a 2-1 as well and just kind of see what that feels like. So that one's staying by itself. This one's moving a bit faster. Oh, a bit faster than it was before, which is good. That's what we want. And the rest of these are moving slow. So it adds some variability to the game and makes it a little bit more dynamic and interesting. Okay, so play around with your walls, get them to be moving in different rates and stuff, make it a little bit fun. Oh, also, by the way, down here, the end of our game, we don't want our walls moving. So let's just set those to 0 because that's going to be the end of our level. Okay, now at this point, we've done basically everything we need to do, and we're at about 30 minutes. But the last thing I want to do is I want to show you how to build this project so that you can show it off to friends and family, and you can turn it in properly. So far we've only turned in our scripts, but I want to show you how to build this game so that you can put it on a flash drive and then take it home and like let people play it and say, hey, look what I built. I made this game, and it's really cool, and it's totally not a ripoff of Flappy Bird. Okay, so what we're going to do is we're going to come over here to File, go to Build Settings, and then in here, you want your main scene to be in the Scenes to Build menu. Let's actually save our game first. I just realized I haven't done that. Save project. Now we'll go to Build Settings. Now I want this main scene to be in the Scenes in Build. Stop right now. Right now, stop. Okay. If you don't put your scene in this menu, your game will not work. You'll build it and it'll be an empty game and nothing will happen. So we want to click Add Open Scenes so that we have this scene in the Build menu. We have this scene in the Build, I guess, array, the array of scenes that are going to be built. Down here we have our platform. This is, we want to keep it on PC, Mac, and Linux. Notice there are other platforms we can publish to, but we're not going to worry about those right now. We're just going to publish to the PC platform. We want to make sure it's 86-bit Windows. Let's see. Let's go to Player Settings and take a look there. So in Player Settings, we can change the name of the game. We can change the name of the company. We can change the icon or the cursor. Let's actually change the icon to something. Let's see. No, that's weird looking. Oh, maybe not change the icon. That's weird. That's gross. All right, never mind. We'll just set it to none. We can change the cursor within the game. We do all kinds of stuff. I want to go to Resolution and Presentation, and let's turn off full screen. Let's make it windowed because we haven't programmed in any way to kill this game once we've started playing it, and so we want to allow ourselves to play it in a window where we can click the X when we're done with the game. All right. Let's see. You can change your splash image in here. You can add in your own splash screen and your own logos and all that stuff. But this looks pretty good. The important thing in here is to change the full screen mode to windowed. All right, now that we're done, let's go ahead and click Build. Now it's going to try to put this build back into the same folder as your project. I don't like that, okay? We want it to be a bit cleaner and separate. So I'm going to right click and I'm going to go to the desktop. Sorry, I'm going to the desktop and I'm going to right click on the desktop and create a new folder. And I'm going to call it Flappy Fish Build. And then inside the Flappy Fish Build, that's where I'm going to build my game. So it's going to take it a moment while it puts everything together and actually builds my game. Now, once it's done, you can actually double click on this icon to play your game. And it will open up with the Unity logo and everything else, and then just let you play your game, which is pretty fun. Now, to turn this in, we want to find that build project, right-click, send to compressed folder, and that will build it as a compressed folder, and so you can turn it in on Canvas. Okay, this video has been long enough. I'm going to go ahead and stop before we hit 35 minutes. Have fun with this project and let me know if you need any help. Peace.